The universe exists in a state of 1/1000th of a second old, a period of such concentrated intensity that the concept of space and time as we understand them is stretched to the point of breaking. This is not the cold, empty void of the modern era, but a blinding, suffocating ocean of pure, unadulterated energy. It is a realm of choking radiance, a searing fog of plasma where every particle is packed so tightly against its neighbour that light itself cannot travel. Photons, the messengers of illumination, are trapped in a frantic, eternal dance of collision, unable to move more than a fraction of a millimetre, before being deflected by the crushing density of the nascent cosmos. In this chaotic dawn, the vacuum of space does not merely expand, it screams as it tears outward, forced into existence by an incomprehensible pressure that seeks to fill the nothingness. There are no stars in this landscape, no galaxies to anchor the eye, and no heavy elements to form the foundations of a future world. The very laws of physics are still being written in a language of fire and fury. Yet, amidst this roiling sea of light and heat, the fabric of reality is not uniform. It is a landscape of mountains and valleys made of sheer density. In certain regions, the chaotic fluctuations of the beginning create ripples where matter and energy are concentrated with terrifying efficiency. In these tiny pockets, the local gravity becomes so profound that it overcomes the outward rush of the cosmic expansion. While the rest of the universe is being driven apart, these regions do the opposite. They buckle under their own weight, their geometry folding inward until the fabric of space-time snaps. These are the firstborn of the cosmos, the primordial black holes. They are an architectural heresy, born not from the long, slow death of a massive star, but from the raw power of the beginning itself. They bypass the traditional cycles of stellar evolution entirely, emerging into the lightless fog before the first atom of hydrogen had even cooled enough to form. They are entities born of pure pressure, ancient pockets of gravity that serve as the original architects of the invisible. Some are forged with the mass of a mountain range but compressed into the volume of a single subatomic particle, while others are gargantuan pits of shadow that could swallow entire solar systems before they even began to coalesce. They are the silent sentinels of the first second, locked in a state of eternal stasis while the rest of the universe begins its long journey of change. 13.8 billion years have passed since that initial scream of creation. The searing plasma has long since cooled, thinning out to form the vast, dark stretches of the modern night sky. The first generation of stars has lived, burned with a fierce intensity, and died, scattering their elemental ashes across the void to form the planets and the sentient beings who now look up at the heavens. Yet the ghosts of that first billionth of a second remain. They are the ultimate survivors, drifting through the silence of the interstellar void, invisible and untouchable. They do not age, they do not decay, and they do not reveal themselves to the light. They move through the outer reaches of our own solar system, their presence hidden behind a veil of perfect shadow, known only by the subtle, ghostly tug they exert on the orbits of distant, frozen worlds. They may even pass through the thin, fragile layer of our atmosphere, or glide through the very rooms where we stand, as ephemeral as a passing thought, but as heavy as a planet. We live in a universe defined by the light of stars, but we are surrounded by a graveyard of ancient shadows that have been waiting since the dawn of time to be recognized. These primordial black holes are the anchors of a hidden sea, the original seeds around which the structure of reality was woven. They represent a fundamental departure from the story of the stars, a reminder that the abyss is not just a place we might one day encounter, but the very crucible from which we emerged. They are the ultimate testament to the violence and the beauty of the beginning, a collection of ancient wanderers that have seen the birth of every light in the sky and will likely remain long after the last star has flickered into extinction. The existence of these objects remains one of the most profound mysteries in the history of human thought. For decades, the consensus of the scientific community held that black holes were merely the final chapters of a stellar biography, the dark punctuation at the end of a brilliant life. To suggest that they could exist without a mother star was to challenge the very understanding of how the cosmos organized itself from the chaos. Yet, as our instruments peer deeper into the dark, the echoes of the first second grow louder and more insistent. We are beginning to realize that the universe we see, the brilliant tapestries of nebulae and the spiraling arms of galaxies, is merely a thin crust of luminous matter floating atop a much deeper, darker, and more ancient ocean. These primordial black holes are the remnants of that original depth, the silent witnesses to the moment space and time were forged in the white heat of the beginning. The shifting tides of scientific consensus began to turn in the early 1970s, a decade defined by a radical rethinking of the dark corners of the cosmos. At the centre of this intellectual storm stood a young Stephen Hawking, a man whose mind roamed the furthest reaches of the theoretical landscape even as his physical world began to contract. At the time, the scientific establishment viewed black holes through a very specific lens. They were the inevitable, crushing endpoints of the most massive stars in the universe. The narrative was linear and biological. A star lived, exhausted its nuclear fuel, and collapsed under its own gravity into a singular point of no return. This was the stellar graveyard, a place where only the corpses of giants were permitted to dwell. To suggest that a black hole could exist without the prior life of a star was seen as a violation of the natural order of the heavens. Hawking, however, possessed a vision that reached back past the first stars into the raw, unformed chaos of the initial expansion. He realized that the conditions of the early universe were so extreme that the crushing pressures required to create a black hole were already present everywhere. In those first fleeting moments, the density of the entire cosmos was greater than that of an atomic nucleus. If the early universe was even slightly lumpy, with some regions being denser than others, those regions would not just expand, they would collapse. This was the birth of a heresy. It suggested that the universe was not just a nursery for stars, but a factory for small, ancient monsters that could be as light as a mountain or as heavy as a planet, yet no larger than a single proton. Working alongside Hawking was a brilliant Doctor of Philosophy student named Bernard Carr. Together, they began to map the impossible. They spent their days submerged in complex equations, translating the violence of the Big Bang into a mathematical framework for these primordial entities. Carr was the cartographer of this invisible realm, calculating the various sizes and masses these objects could take depending on exactly when they formed in the first second of time. They found that if these black holes were born early enough, they could be incredibly small, yet possess a gravitational grip that would last for billions of years. This partnership produced a body of work that functioned as a forgotten prophecy, a set of theoretical blueprints for a population of objects that no telescope of the era could ever hope to see. The response from the wider scientific community was one of polite but firm dismissal. To the veterans of the 1970s, primordial black holes were seen as mere mathematical curiosities, the kind of abstract puzzles that kept theorists busy but had no basis in the physical reality of the sky. The prevailing wisdom held that if something could not be observed or did not fit into the established life cycle of a star, it likely did not exist. The idea of a black hole the size of an atom wandering through the solar system felt more like science fiction than serious physics. These objects were treated as ghosts in the machine, elegant on paper, but irrelevant to the grand tapestry of the observable universe. The establishment remained focused on the massive, the visible, and the predictable, leaving Hawking and Carr's work to gather dust in the archives of theoretical journals. Yet, the prophecy remained, etched in the language of mathematics. Hawking and Carr had established a fundamental departure from the stellar narrative, decoupling the existence of black holes from the death of stars. They had proposed a universe that was far more crowded and complex than anyone had dared to assume. They suggested that the darkness was not just an empty void waiting to be filled by the light of the first suns, but a populated landscape of ancient shadows that had been there since the very first heartbeat of time. This was a vision of a universe that remembered its own birth, carrying the scars of its violent origin in the form of indestructible pits of gravity. As the decades progressed, the quiet work of these two men would evolve from a fringe curiosity into a central pillar of our search for the missing pieces of the cosmic puzzle. The heresy of the 1970s was destined to become the foundation for a new understanding of the dark matter that holds the very stars together. The significance of their work lay in the realization that these primordial entities were the only objects in the universe that could act as perfect time capsules. While stars burn out and galaxies collide and reshape themselves, a black hole formed in the first trillionth of a second remains virtually unchanged for 13.8 billion years. It carries the density, the temperature, and the raw energy of the beginning within its event horizon. Hawking and Carr had not just discovered a new type of celestial object. They had discovered a way to touch the moment of creation itself. They had shown that the beginning of time was not a distant, unreachable event, but something that could be drifting past us in the dark, a silent witness to the entire history of existence, waiting for our technology and our courage to finally catch up with the mathematics of the 1970s. The cosmos in its infancy behaves not like a vacuum, but like a thick incandescent fluid. It is a primordial ocean of energy, roiling with a violence that defies the quietude of the modern night. In this era, matter as we know it, atoms, molecules, dust, does not exist. Instead, there is only a screaming soup of elementary particles and raw radiation packed so densely that the entire observable universe is smaller than the tip of a needle. The pressure within this fluid is absolute, a crushing weight that forces every point of space to vibrate with the intensity of a billion suns. This is the forge of reality, a place where the distinction between light and solid matter has yet to be drawn. The fluid dynamics of this early state are governed by extreme heat and the relentless outward drive of the Big Bang, creating a landscape where space-time itself acts as a viscous, turbulent sea. Within this incandescent sea, the surface is never smooth. Even at the most fundamental level, the universe is restless and uneven. Quantum fluctuations, tiny erratic shudders in the fabric of existence, flicker in and out of being. Under normal circumstances, these ripples would remain confined to the subatomic realm, mere whispers in the static of the beginning. However, the mechanism of cosmic inflation intervenes. In a duration shorter than 1/1,000,000,000th of a second, the fabric of space-time undergoes a spasm of expansion so violent that it outpaces the speed of light itself. These microscopic ripples are caught in this sudden surge, stretched and pulled until they span vast distances. What was once a subatomic tremor becomes a massive mountain of density, a concentrated surge in the primordial tide that ripples through the plasma soup. As the era of inflation ends, the universe is left with a landscape of uneven terrain. Most regions continue to thin out as the expansion carries on at a more measured pace, but those areas where the density was spiked during the initial spasm find themselves in a state of precarious imbalance. The surrounding plasma soup, driven by the extreme heat of the Big Bang, exerts a colossal outward pressure, yet the concentrated mass of the density spike pulls inward with a gravitational force that is relentless and absolute. In these specific locations, the equilibrium of the cosmos shatters. The inward pull of gravity triumphs over the outward push of radiation. The region stops expanding with the rest of the cosmos. It stalls, shudders under the weight of its own existence, and then begins to fall into itself. The transition is a spectacle of pure, unbridled physics. The plasma within the density spike is hammered by gravity into a state that defies the limits of ordinary matter. The temperature in these localized pits skyrockets, reaching billions upon billions of degrees, as energy is packed into an ever-shrinking volume. The light is strangled, unable to escape the intensifying gravitational well. The roiling heat is compressed until the very geometry of space-time warps and buckles. Where there was once a screaming wave of energy, there is suddenly a silent, absolute void. The fabric of the universe tears asunder, sealing a portion of that primordial density away from the rest of existence. A primordial black hole is born, an eternal pit carved out of the white-hot furnace of the beginning, tempered by the extreme pressure of the early soup. These objects are the ultimate survivors of the forge. While the rest of the universe continues to cool and expand, becoming the transparent star-filled expanse recognized by modern astronomy, these black holes remain as they were created. They are the concentrated essence of the first second, locked behind event horizons that no light can ever escape. They do not require the death of a star because they were born when the entire universe was more dense than any star could ever be. They are the solid remnants of a fluid age, drifting through the evolving cosmos like stones at the bottom of a river. As the plasma soup eventually thins and the first atoms form, these silent voids remain, invisible anchors in a sea of changing light, carrying the secrets of the beginning within their dark, unreachable hearts. The forge of the early universe was not a uniform process. Because the ripples in the density of the plasma were of various sizes, the black holes they created spanned a vast spectrum of mass. Some were forged from the smallest quantum tremors, resulting in entities with the mass of a massive mountain, but the physical dimensions of a single proton. Others were born from larger swells in the primordial ocean, resulting in monsters that could rival the mass of entire planetary systems. Regardless of their size, each one represents a failure of the expansion to overcome the local gravity of the beginning. They are the scars of a struggle between the outward explosion of space and the inward collapse of matter, a struggle that was won by the darkness in the very first moments of time. This era of creation was brief, a window that closed as the universe expanded and the density of the plasma soup dropped below the threshold required for such spontaneous collapse. Once the first few seconds had passed, the conditions necessary to forge a black hole from pure pressure vanished forever. The universe transitioned from a state of chaotic creation to a state of slow, structured evolution. But the primordial black holes were already there, scattered throughout the expanding void. They were the first permanent structures in the history of the cosmos, predating the first stars by hundreds of millions of years. They watched as the first atoms of hydrogen and helium formed from the cooling plasma, and they waited in the dark as the first clouds of the gas began to huddle together under the influence of their ancient invisible gravity. The universe began its slow descent from the white heat of the beginning into the long, cold expanse of the future. Yet these primordial voids remained defiant of the passage of time. Unlike the ephemeral structures of the visible world, which are subject to the relentless laws of entropy and decay, a primordial black hole possesses a terrifying and absolute permanence. A star is a complex machine, a delicate balance between the inward crush of gravity and the outward blast of nuclear fusion. It requires a constant supply of fuel, and eventually that fuel must run dry. When a star dies, it sheds its outer layers in a violent paroxysm, or collapses into a new, degraded form, leaving behind a remnant that is fundamentally different from its parent. But a primordial black hole is not a machine. It is a knot in the geometry of space itself, a singular point where the laws of physics have folded the fabric of reality into an unbreakable loop. It has no internal parts to wear down, no burning core to exhaust, and no complex chemistry to decay. It is the ultimate expression of simplicity, defined only by its mass, its spin, and the curvature it imposes on the void. Because of this structural purity, these entities have endured for 13.8 billion years, remaining virtually identical to the moment they were forged in the searing pressure of the first second. Each primordial black hole acts as a perfect time capsule, a sealed vault containing a sample of the density and energy of the universe as it existed in the first fraction of existence. Within their event horizons, the conditions of the dawn of time are locked away, protected from the dilution and cooling that have defined the rest of cosmic history. While the surrounding universe expanded and its temperature plummeted from trillions of degrees to the near absolute zero of the modern era, the interior of these holes remains a sanctuary of the original fire. They are the only objects in existence that have not been recycled through the long, messy cycles of stellar birth and death. They are not made of the heavy elements forged in the hearts of stars. They are the raw, unadulterated material of the creation itself, preserved in a state of eternal stasis. To look upon one, if such a thing were possible, would be to look directly into the face of the beginning, a piece of the primordial furnace that has survived the cooling of the cosmos. As the eons unfolded, these ancient shadows drifted through a universe that was slowly and painfully transforming. During the long, dark ages, an epoch that lasted for hundreds of millions of years before the first star had ever dared to ignite, the primordial black holes were the only concentrated sources of gravity in the vast, cooling clouds of hydrogen and helium gas. They acted as silent anchors, their invisible influence pulling the primordial gases toward them, helping to create the first seeds of structure in an otherwise featureless void. They were the dark foundations upon which the first light would eventually be built. When that light finally broke across the cosmos, the era of reionization, these black holes were already ancient veterans of the void. They watched as the first massive stars flickered into existence, burning with a blue-white ferocity that lasted only a few million years before they exploded into supernovae. To a primordial black hole, the life of a star is a mere spark, a brief and frantic flash of light in an otherwise eternal darkness. The journey of these shadows continued as the universe grew older and more complex. They witnessed the chaotic assembly of the first galaxies, where vast clouds of gas and millions of early stars collided and merged in a slow-motion dance of gravity. In the heart of these burgeoning stellar cities, some primordial black holes may have served as the foundational stones, merging with one another to form the seeds of the supermassive monsters that now dwell in the centres of every major galaxy. Others remained solitary wanderers, drifting through the spiralling arms of the developing Milky Way. They saw our own sun coalesce from a cloud of recycled stellar debris 5 billion years ago, and they watched as the planets took shape from the leftover dust of a forgotten supernova. Throughout all these transformations, the primordial black holes remained unchanged, their dark surfaces reflecting nothing, their presence felt only by the subtle warping of the space through which they moved. There is a profound contrast between the fleeting lives of the luminous matter we see and the eternal nature of these ancient shadows. Every atom in the human body, every grain of sand on a beach, and every star in the sky is the result of a long chain of cosmic recycling. We are made of the remnants of dead suns and the debris of ancient collisions. Our existence is a temporary arrangement of matter that will eventually be scattered once more across the void. But a primordial black hole is a singular event, a permanent scar on the fabric of reality that does not participate in the cycle of birth and death. It is a piece of the beginning that will likely persist until the very end of time, long after the last star has burned out and the last galaxy has dissolved into the expanding dark. They are the silent witnesses to every major epoch of cosmic history, from the first light to the formation of the Milky Way, standing as a reminder that the universe has a memory that does not fade, and that the darkness was here long before the light ever dreamed of shining. This endurance makes them the ultimate observers of the cosmic drama. They have seen the universe grow from a pinprick of fire to a vast expanse of billions of light years. They have watched the rise and fall of countless stellar generations, the birth of planetary systems, and perhaps even the emergence of life on worlds that have since been swallowed by their own dying suns. Through it all they have remained the same, dark, silent and heavy with the weight of the beginning. They are the ghosts of a vanished age drifting through a world that has forgotten its origins, yet carrying those origins within them like a secret that can never be told. As we peer into the depths of the night, we are not just looking at the light of distant stars. We are looking through a sea of these ancient shadows, the indestructible remnants of the moment the universe first opened its eyes. The beauty of the visible universe, the spiraling arms of galaxies, the glowing nurseries of nebulae, and the steady light of 1 trillion stars, is a deceptive facade, a thin layer of illumination masking a much deeper and more profound reality. When the motions of these celestial structures are measured with precision, a startling anomaly emerges that shatters the traditional understanding of the cosmos. The stars at the outer edges of a spiral galaxy travel with a ferocity that defies the visible mass of their home. According to the laws of gravity dictated by the matter we can see, these peripheral stars should be flung into the intergalactic void, unable to be held by the meagre pull of the luminous core. Yet they remain tethered, orbiting as if gripped by an immense unseen hand. This is the great mystery of modern cosmology, the realization that the weight of the universe does not reside in the things that shine. Careful observations and mathematical models have revealed a staggering truth that humbles the entire history of human observation. 85% of all the matter in the universe is completely invisible, untouchable, and utterly silent. It does not emit light, it does not reflect the glow of nearby suns, and it does not cast a shadow against the background of the Big Bang. It is a ghost matter that interacts with the rest of reality only through the relentless, inescapable pull of gravity. For decades, this missing mass has been labelled dark matter, a placeholder for an identity we have struggled to uncover. The search for this substance has become a desperate obsession, a multi-generational hunt that has pushed the limits of our technology and our imagination. In the pursuit of this invisible majority, the scientific community has constructed vast, silent cathedrals of technology. Detectors the size of buildings have been buried deep beneath the earth, shielded by kilometres of solid rock to filter out the noise of the surface world. There, in the absolute dark, researchers wait for a single, tiny spark, a sign that a hypothetical dark matter particle has finally brushed against the atoms of our world. They have theorized about weakly interacting massive particles, subatomic entities that might flood the universe like a transparent sea. Yet, year after year, the detectors remain silent. The sparks do not come. The particles remain confined to the chalkboards of theorists, and the mystery of the missing weight only grows more heavy. The realization is beginning to settle in that we may have been looking for the wrong thing entirely, searching for a whisper when the answer is a roar. In this atmosphere of growing uncertainty, the ancient heresy of the 1970s has returned to the forefront of the cosmic conversation. If dark matter is not a new, exotic particle, then it must be something far more familiar, yet far more terrifying. The primordial black holes, those ancient pockets of gravity forged in the first billionth of a second, emerge as the ultimate candidate for the missing weight of the cosmos. They fit every requirement of the dark matter profile. They are dark by their very nature, they possess immense mass, and they have been present since the very first heartbeat of time. Instead of a universe filled with a mist of subatomic particles, we may be living in a cosmos populated by a vast hidden swarm of these ancient shadows. This perspective shifts the very architecture of reality. The galaxies we see are not independent islands of light floating in an empty void. Instead, they are the luminous foam on the crest of a massive invisible wave. The light of the stars is merely a dusting of snow on a much darker, heavier mountain range of ancient shadows. This is the cosmic skeleton, a hidden framework of primordial gravity that dictates the shape and the destiny of everything we can see. These black holes are the anchors around which the first clouds of gas gathered, the gravitational seeds that allowed the large-scale structure of the universe to form. Without this dark scaffolding, the gas and dust of the early universe would have remained scattered and thin, never coalescing into the brilliant stellar cities that now populate the night sky. The search for dark matter is no longer just a hunt for a particle, it is an investigation into the foundational history of the universe. If 85% of the matter is composed of primordial black holes, then the story of the cosmos is not the story of light, but the story of the dark. We are the inhabitants of a luminous minority, living on the fringes of a much older and more substantial world of shadows. These entities are the true masters of the gravitational landscape, the silent architects that hold the Milky Way together and prevent the sun from drifting into the loneliness of deep space. They are the invisible giants upon whose shoulders the visible universe rests. As we look out into the depths of the night, we must confront the reality that our eyes perceive only a fraction of what is truly there. The vast gaps between the stars are not empty. They are filled with the weight of these ancient survivors. We are drifting through a sea of primordial voids, a hidden population of mountain mass objects that have endured since the beginning. They are the ultimate testament to the complexity of the Big Bang, a reminder that the universe is far more crowded than it appears. The mystery of the missing weight is not a failure of our equations, but a revelation of our blindness. We are finally beginning to see the shape of the cosmic skeleton, the dark and ancient bones of the universe that have been waiting for 13.8 billion years to be recognized. The light is a beautiful distraction, but the shadows are the truth. To uncover these elusive architects of the dark, science must rely on a phenomenon that treats the very fabric of space as an optical instrument. According to the foundational principles of relativity, gravity is not merely a force that pulls on matter, but a curvature in the geometry of the universe itself. When a primordial black hole drifts through the void, it carries with it a profound distortion of space-time, a localized well that forces everything in its path to follow its warped contours. This includes light. Even though these ancient shadows are perfectly dark and emit no radiation of their own, they cannot hide the way they manipulate the light of the stars that lie far beyond them. They act as a lens of pure gravity, a cosmic magnifying glass that reveals the presence of the invisible by bending the path of the visible. This process, known as gravitational lensing, occurs when a primordial black hole passes directly between a distant star and an observer on Earth. As the dark wanderer moves into alignment, its intense gravitational field acts like a glass lens, gathering the light rays from the distant star that would otherwise have streamed past us and focusing them toward our telescopes. From our perspective, the star does not appear to move, but it undergoes a sudden, characteristic surge in brilliance. This is not the flickering of a dying sun or the violent outburst of a supernova, but a symmetric, rhythmic brightening and dimming that signals the passage of a hidden mass. It is as if a ripple has moved across the surface of a still pond, momentarily distorting the reflection of the sky above. The hunt for these flickers of light requires a level of patience and precision that borders on the monumental. Because primordial black holes are likely scattered sparsely across the vast reaches of the galactic halo, the probability of any single star being lensed at any given moment is incredibly low. To catch a shadow in the act of bending light, astronomers must turn their instruments toward the most crowded regions of the sky, such as the dense stellar fields of the Magellanic Clouds or the spiraling heart of the Andromeda Galaxy. They scan millions of stars simultaneously night after night for years on end, using automated systems to watch for the one-in-a-million event where a star's light swells and then fades with mathematical perfection. Each of these detections is a precious data point in the map of the unseen. By analysing the duration and the intensity of the brightening, researchers can calculate the mass of the invisible object that caused the distortion. A lens that lasts for only a few hours might be caused by an object with the mass of an asteroid, while a brightening that persists for weeks suggests a much more gargantuan entity. Through these observations, the scientific community is attempting to weigh the shadows themselves, determining if there are enough of these primordial survivors to account for the 85% of matter that remains missing from our equations. It is a search for the ghosts of the Big Bang conducted by watching the way they haunt the light of the modern universe. The imagery of space itself acting as a lens provides a profound shift in how we perceive the vacuum. The void is not a passive container for the stars. It is a dynamic, flexible medium that can be stretched and curved by the weight of ancient history. When we look at a distant galaxy through a telescope, we're not looking through a clear window, but through a sea of gravitational ripples created by the hidden population of the dark. Every beam of light that reaches our eyes has been nudged and steered by the invisible masses it encountered during its journey across the eons. The universe is a house of mirrors, where the geometry of reality is constantly being reshaped by the presence of these primordial voids. Despite the elegance of this method, the search remains fraught with challenges. The smaller the primordial black hole, the more fleeting and difficult the lensing event becomes. For those objects that possess the mass of a mountain but the size of a single atom, the distortion of the light is so minuscule and occurs so rapidly that it pushes the very limits of our current detection technology. We are searching for a needle of shadow in a haystack of radiance, looking for a momentary pulse of light that might only last for a fraction of a second. Yet, it is through these brief, elusive signals that we hope to confirm the existence of the firstborn structures of the cosmos. This gravitational hunt is the only way to bridge the gap between the visible world and the dark majority. It allows us to perceive the cosmic skeleton that holds the galaxies together, providing a tangible link to the events of the first billionth of a second. Every successful detection of a lensing event is a victory over the silence of the void, a confirmation that the ancient shadows are not just theoretical constructs but physical realities that continue to influence the motion of light and matter. We are learning to read the ripples in the pond, deciphering the story of the beginning by watching the way the darkness plays with the light. The lens of pure gravity is our only hope of seeing the unseeable, of finally understanding the true weight of the mountain range of shadows that defines the architecture of the universe. The solar system drifts through the galactic suburbs as a target in a cosmic shooting gallery, where the projectiles are invisible, ancient, and move with a lethality born of the beginning of time. This is the cosmic lottery, a statistical game played across billions of years. While the vast distances between stars suggest a lonely existence, the sheer number of primordial black holes potentially populating the dark matter halo means that encounters are not a matter of if, but when. Somewhere in the deep dark, far beyond the orbit of Neptune, a shadow forged in the first trillionth of a second begins its approach. It possesses the mass of 1 billion tons, a mountain of heavy rock and iron, yet its physical extent is smaller than a single atom of hydrogen. It is a point of infinite density, a microscopic puncture in the fabric of reality, travelling at 400 kilometers per second. There is no warning. No telescope can detect its approach because it reflects no light and casts no shadow against the distant stars. It does not possess the gas-driven tail of a comet or the rocky silhouette of an asteroid. It is a silent intruder, moving through the vacuum with a singular unwavering purpose dictated by the gravitational currents of the Milky Way. As it crosses the threshold of Earth's atmosphere, there is no brilliant streak of fire. Unlike a meteor, which is broad enough to collide with air molecules and incinerate through friction, this primordial black hole is so infinitesimally small that it slips between the atoms of the nitrogen and oxygen as if they were vast, empty cathedrals. It passes through the thermosphere and the stratosphere in a fraction of a heartbeat, a ghost moving through a veil. The impact with the solid crust is not an explosion, but a piercing. The primordial black hole strikes the ground and enters the rock like a hot needle passing through silk. The resistance of the granite and basalt is irrelevant to an object whose gravitational pull at its surface is billions of times stronger than the structural bonds of any solid matter. It does not slow down. It does not deflect. It simply continues its journey, carving a microscopic tunnel through the lithosphere. Behind it, the matter it has touched is not just crushed, it is consumed or vaporized by the intense tidal forces and the sudden release of energy as the hole's event horizon grazes the atomic structure of the Earth. As the object transits the interior of the planet, the Earth begins to respond to the violation. Though the hole is small, its passage creates a wake of intense physical phenomena. It acts as a moving source of gravitational radiation and localized heating. Along its path, the rock is briefly accelerated toward the point of infinite density, creating a shock wave that radiates outward. This is the seismic signature of the ancient shadow, a unique, needle-like tremor that moves through the mantle at supersonic speeds. Unlike the broad rolling waves of a tectonic earthquake, this is a sharp, focused acoustic pulse, a scream of the Earth's interior as it is lanced by a relic of the Big Bang. Deep within the outer core, where liquid iron flows in great convective loops, the primordial black hole leaves a trail of glowing plasma. The intense gravity of the object pulls at the molten metal, creating a brief, violent vortex. As the iron is drawn toward the event horizon, it is compressed and heated until it emits a signature of hard X-rays and gamma radiation. This radiation is trapped deep beneath thousands of kilometers of rock, but the energy contributes to the seismic wake, a thermal scar left in the heart of the world. The planet rings like a bell struck by a subatomic hammer, a vibration that travels from the core to the surface, detectable only by the most sensitive instruments designed to listen to the heartbeat of the globe. The transit is over in less than 2 minutes. The primordial black hole exits the opposite side of the planet, bursting through the crust and back into the vacuum of space, with the same 400 kilometers per second velocity it possessed upon entry. It leaves behind a microscopic exit wound and a world that is fundamentally changed, even if the inhabitants on the surface remain unaware of the encounter. The total energy deposited into the Earth is equivalent to a significant earthquake, but because it is distributed along a narrow line through the center of the globe, the surface effects are subtle, a series of strange, unexplained tremors and a momentary spike in the background radiation of the deep crust. This event highlights the terrifying fragility of our world. We exist on a thin layer of cooled rock, protected by a fragile envelope of gas, while the universe around us is populated by invisible bullets that can pierce our home without effort. There is no defense against such an encounter. There is no shield that can stop a point of infinite density. We are at the mercy of the cosmic lottery, drifting through a sea of ancient shadows that have been wandering since the 13.8 billion-year-old dawn. The silence of the event is its most haunting quality. A mountain mass object can pass through our very foundations, and unless we are looking for the specific seismic scream of its passage, we would never know that we had been touched by the beginning of time. The exit of the black hole into the dark is as quiet as its arrival. It continues its journey toward the inner solar system or out into the interstellar void, its mass and velocity unchanged by the encounter. It carries with it the same conditions of density and pressure that existed when the universe was less than a second old, a perfect time capsule that has just sampled the interior of a living world. Behind it, the Earth continues its orbit, a silent witness to the fact that we live in a graveyard of ancient shadows. We are small, we are soft, and we are transparent to the most powerful forces in the cosmos. The encounter is a reminder that the abyss is not just out there among the stars. It is a traveller that can move through us at any moment, leaving only a ripple in the dark and a shudder in the rock to mark its passing. The moon hangs in the velvet dark as a pristine ledger of the solar system's violent biography, a world without the erasing power of wind, water, or tectonic renewal. For 4.5 billion years it has stood as a silent witness to the debris of the beginning, its face scarred by the impact of countless asteroids and comets. These traditional collisions are messy, surface-level affairs. A rock weighing 1 million tons strikes the lunar regolith and vaporizes instantly, creating a bowl-shaped crater and spraying a blanket of ejecta across the airless plains. The history of the moon is written in these circular depressions, a visual record of the chaotic assembly of the planets. Yet, as our mapping of the lunar surface becomes more refined, reaching a resolution that can distinguish the smallest features, astronomers began to look for a different kind of wound, one that does not fit the profile of a falling rock. A primordial black hole, possessing the mass of a mountain but the physical dimensions of a subatomic particle, would not create a traditional crater. It would not explode upon contact with the lunar surface because it has no surface area to provide resistance. Instead, it would operate with the surgical precision of a ghost, striking the moon at hundreds of kilometers per second and passing through the entire body of the satellite like a needle through a pearl. This would leave a distinct needle-like puncture, a microscopic tunnel of fused glass and shattered crystal that extends from one side of the moon to the other. The entry point would be marked not by a massive crater, but by a small intense zone of seismic melting, where the lunar rock was briefly subjected to tidal forces that mimic the conditions of the Big Bang itself. Searching for these punctures is the ultimate challenge of planetary archaeology. The lunar crust is a fossilized record of the early solar system, but the signature of a primordial black hole is incredibly subtle. We look for linear anomalies, long, narrow features in the lunar crust that cannot be explained by volcanic activity or the cooling of the interior. We look for seismic data from the Apollo era that might show the moon ringing with a sharp, focused acoustic pulse, a vibration that originated not from a surface impact, but from a transit through the very core. To find such a scar would be to confirm that our solar system is not a closed system, but a place that is constantly being lanced by the dark remnants of the first second of time. This realization forces a terrifying recalibration of the human scale of the infinite. We are accustomed to thinking of the universe as a distant theatre of light, a place that we observe from the safety of our atmospheric cocoon. But if the dark matter that binds our galaxy is indeed a vast swarm of these ancient entities, then the gaps between the stars are not empty, and the space between our worlds is crowded with invisible bullets. The probability of an asteroid hitting the Earth is low enough to provide a sense of security over a human lifetime, but the density of primordial black holes required to explain the missing mass of the universe suggests a far more frequent interaction. They are not just out there among the distant galaxies, they are here, moving through the air we breathe and the structures we build. At any given moment, a primordial black hole with the mass of a mountain but the size of an atom could be transiting our atmosphere, its passage marked only by a faint, undetectable trail of ionized gas. It could be moving through the steel and glass of our skyscrapers, passing through the very floors where we stand, and we would be none the wiser. Because they are so small, They almost never collide with the nucleus of an atom. They slip through the vast empty spaces within the molecular structure of our world. They are the ultimate ghosts, mountain mass wanderers that can pass through a human body without leaving a mark, their presence felt only by a gravitational tug so brief and so localized that no human sense could ever perceive it. We are surrounded by a hidden population of millions of these invisible bullets, a dark rain that has been falling through the solar system since before the Earth was born. This is the fragility of our existence. We live in a world of light and solid matter, yet we are immersed in a sea of ancient shadows that treat our planet, our homes, and our very bodies as if they were made of nothing but empty space. We are the inhabitants of a luminous minority, trying to make sense of a reality that is dominated by things we cannot see and cannot touch. The moon stands as a reminder of this vulnerability, a target that has been sitting in the path of the dark matter swarm for billions of years, potentially carrying the punctures of 1,000 transits in its cold, silent heart. The thought of these objects moving through our immediate environment is a reminder that the abyss is not a distant destination, but a fundamental part of the room where you sit. The fabric of reality is not a solid, impenetrable wall. It is a porous mesh, and the primordial black holes are the threads that have been woven through it from the very beginning. We move through our lives with a sense of permanence and solidity, but we are drifting through a graveyard of ancient shadows that move with a velocity and a power that mock our brief history. We are touched by the infinite every day, lanced by the remnants of the first trillionth of a second, and it is only our blindness and the sheer scale of the universe that allow us to maintain the illusion of our own isolation. The search for the scars on the moon is not just a scientific endeavour, it is a search for our own place in a universe that is far more crowded, far more ancient, and far more dangerous than we ever dared to believe. The vacuum of space is not a true nothingness, but a roiling sea of quantum potential, a landscape where particles and their antimatter counterparts flicker into existence and vanish in a duration too brief for the laws of classical physics to register. At the very edge of a black hole, the event horizon, this subatomic restlessness takes on a transformative character that shatters the concept of the perfect void. When a pair of these virtual particles emerges at the exact boundary of the shadow, a cosmic theft occurs. The relentless gravity of the hole snatches one particle, pulling it down into the abyss, while the other is left stranded on the threshold of the observable universe. Deprived of its partner with which to annihilate, the surviving particle is forced to become real, escaping into the dark as a tiny pulse of radiation. Because the energy to create this new particle must be accounted for, it is stolen directly from the mass of the black hole itself. This is Hawking radiation, the slow, agonizing leak of energy that ensures that no shadow, no matter how ancient or powerful, is truly eternal. This process is a reversal of the traditional narrative of gravity. Instead of only consuming, the black hole is now forced to give back to the universe, one particle at a time. However, the rate of this leakage is dictated by a cruel and inverse relationship with size. A massive black hole, the kind born from a dying giant or dwelling in the centre of a galaxy, is so cold and its evaporation so slow that it would take more years than there are atoms in the observable universe to vanish. But for the primordial black holes, those forged in the first billionth of a second with the mass of a mountain, but the size of an atom, the clock is ticking much faster. These smaller entities are hotter and more radiant. For 13.8 billion years, they have been drifting through the void, slowly losing their substance to the quantum vacuum, their masses dwindling as they radiate their very essence back into the cold expanse of space. As a primordial black hole loses mass, its temperature begins to climb. The smaller it becomes, the more frantically it leaks energy. What began as a slow, undetectable trickle of radiation over eons accelerates into a runaway process of self-destruction. In the final stages of its life, the black hole is no longer a silent shadow, but a screaming source of heat and light. It begins to glow with an intensity that defies its microscopic size, emitting a torrent of high-energy particles and hard radiation. In the final second of its existence, the process reaches a crescendo. The remaining mass, still equivalent to hundreds of thousands of tons of matter, is converted entirely into energy in a single terminal spasm. The fabric of space-time, which had been curved into a tight eternal knot for billions of years, suddenly snaps back into place. The ancient monster vanishes in a blinding, violent flash of gamma rays, a final breath of pure light that carries the energy of 1,000,000 nuclear explosions. This final flash is the ultimate signature of the beginning of time. It is a signal that has travelled across the eons, a message from the first second of the Big Bang finally reaching the modern era. Astronomers now scan the night sky with sophisticated gamma-ray telescopes, looking for these sudden, isolated sparks in the deep dark. They search for short, intense bursts of high-energy light that do not originate from the collapse of a star or the collision of neutron stars. To find such a spark would be to witness the death of a relic, the final evaporation of an object that was present when the universe was smaller than a grain of sand. Each detected burst is a potential proof of the conditions of the dawn of existence, a confirmation that the early universe was indeed turbulent enough to forge these mountain mass shadows. The search for these final breaths is a hunt for the ultimate truth of our origins. If we can capture the light of a dying primordial black hole, we're not just seeing an explosion. We are looking at the end of a journey that began 13.8 billion years ago. We are seeing the release of energy that has been trapped since the moment space and time were first forged. These sparks are the only way to peer through the veil of the cosmic microwave background, the wall of light that prevents our telescopes from seeing the very first moments of creation. The gamma rays from an evaporating black hole carry the imprint of the density and the pressure of the primordial soup, acting as a bridge between the subatomic world of quantum mechanics and the gargantuan scales of cosmology. There is a profound irony in this search. The very objects we once thought were the ultimate consumers of light, the perfect traps from which nothing could escape, may be the very things that finally illuminate the darkness of our beginnings. We are looking for the light within the shadow, the heat within the cold, and the life within the dead void. Every night, the silent sentinels of the first second are reaching the end of their long, lonely vigil, vanishing in flashes of radiance that momentarily outshine entire clusters of stars. We live in a universe that is slowly evaporating, a reality where even the most indestructible structures are subject to the relentless erosion of the quantum vacuum. The search for Hawking radiation is the search for the final chapter of the primordial story, a reminder that in the grand architecture of the cosmos, even the dark must eventually give way to the light. We scan the heavens not just for the steady glow of suns, but for the sudden terminal flickers of the ancient past, waiting for the universe to reveal the secrets it has held since the first billionth of a second. The luminous era of the cosmos is merely a brief frantic morning, in a day that lasts for an eternity of darkness. As the expansion of space continues its relentless acceleration, the universe marches toward a destiny defined by cold, silence, and the total dissolution of structure. This is the heat death, the final state of maximum entropy, where the gradients of energy that permit life, light, and motion are leveled into a flat, featureless plane. One by one, the stars exhaust their nuclear reservoirs. The brilliant blue giants vanish first, followed by the steady yellow suns, and finally the dim red dwarfs that have clung to existence for trillions of years. Galaxies, once vibrant cities of light, transform into sprawling graveyards of stellar husks, frozen planets, and drifting dust. In this encroaching winter, the primordial black holes emerge as the final undisputed masters of the void. While the visible matter of the universe decays and scatters, these ancient shadows remain. They are the last residents of a freezing expanse, survivors that have already endured for countless eons and are prepared to endure for trillions more. In a universe where the light of the last star has been forgotten for 1 trillion generations, the primordial black holes continue their silent vigil. They drift through a vacuum that has become so vast and so dilute that a single atom may travel for 1 billion years without ever encountering another. To any hypothetical observer, the universe would appear empty. yet it remains populated by these mountain mass entities, the indestructible anchors of a reality that has otherwise evaporated. They are the final repositories of mass, the last concentrated points of gravity in a world that has lost its shape. Yet, even these ancient sentinels are not immune to the slow erosion of time. The quantum leak of Hawking radiation, which was a mere whisper during the era of the stars, becomes the dominant process of the late cosmos. Over spans of time that defy human comprehension, stretching to 10 to the power of 100 years and beyond, the primordial black holes begin to fade. One by one, they reach the end of their long, slow evaporation. In a universe that is otherwise pitch black and near absolute zero, these objects begin to flicker. The final breaths of these ancient monsters manifest as sudden, violent bursts of gamma rays, momentary sparks of heat and light that represent the very last events to occur in the history of the cosmos. These are the final punctuation marks at the end of the cosmic story, the last time the laws of physics will ever produce a concentrated release of energy. When the last primordial black hole has vanished in its terminal flash, the universe undergoes a final, irreversible transition. The matter that these holes once contained is scattered back into the void as a thin, incredibly dilute gas of photons and subatomic particles. Space becomes a sea of pure empty light, stretched so thin by the expansion that the wavelength of a single photon eventually becomes longer than the observable horizon. There are no more stars, no more black holes, and no more shadows. The record of the beginning, which these primordial entities carried within their event horizons for an eternity, is finally erased. The universe becomes a place without memory, a silent expanse where time continues to pass but nothing ever happens again. The abyss, which began as a screaming fog of plasma, ends as a cold, infinite nothingness. We stand now in the brief window of light between these two darknesses, looking up at a night sky that we assume to be a map of the present. We must realize that the gaps between the stars are not empty. We are drifting through a sea of ancient shadows, the leftover debris of the moment of creation itself. These primordial black holes are a reminder that the universe is far older, far heavier, and far more dangerous than our brief history can comprehend. They are the hidden skeletons of the cosmic web, the anchors that allowed the gas to huddle and the stars to ignite. Without these ancient pits of gravity, the atoms that compose our bodies and the ground beneath our feet would never have found one another in the expanding dark. Our ability to even conceive of these entities is the greatest strength of our species. We are a collection of atoms trying to understand the very holes in the fabric of reality that helped sculpt our existence. We are the universe looking back at its own dark foundations, attempting to decipher the forgotten prophecy written in the first billionth of a second. As we peer into the depths of the night, we are not just looking at the light, we are looking at the remnants of a struggle between the outward rush of space and the inward pull of gravity. We live on the edge of the abyss, and that abyss is much closer than we think. It is in the orbits of the outer planets, it is in the air of our atmosphere, and it is in the silent, invisible rain of shadows that has been falling since the beginning of time. We are the children of the light, but we are held in the arms of the ancient dark, and in the end it is to that dark that all things must return.